Okay, so new Jupyter notebook, new Python notebook. So I'm going to go to new Python 3 and name this notebook Pandas stuff. Doesn't matter what you guys name it. Basically, we're going to use this notebook kind of as just code in Scratch throwaway stuff, just so that we could basically get through the concepts of merging and getting the data sets together and all of that stuff basically. Also, tonight I will post a bunch of code examples that I was supposed to post, but they got corrupted. So there are probably like 6 or 7 Jupyter Notebook files that have specific code examples. Even though we didn't explicitly cover NumPy, just for those of you who are interested in learning about it, I also created like 2 or 3 code examples that are specific to NumPy. I'm going to post them just as an FYI. You don't have to go through them if you don't want to, but it's still useful to at least understand the basics of how and why and what it's for. So the first thing, what do I need to do if I want to import a CSV file with Pandas? What do I need to import? Not CSV, but yep, import Pandas as PD. All right, don't want to type those 6 characters, so we're going to type 2 characters. So now that I have my Pandas library imported, I can essentially create my data frame right off the bat. So I'm going to create a variable called df for data frame. You can name it whatever you want. I just tend to name generic data frames as df for data frame, again, because I don't like typing. So df would equal to pd.read CSV and the name of the file as long as it's in your folder. So once we load the CSV file, what is the first thing you should do from last week? What is the first thing you do when you get your data? Describe it or even look at it. So I'm going to do 2 things. I'm going to do, the first thing I always do is look at the header of the data to kind of see what it looks like in general. So this gives me, at least an idea of what columns I'm dealing with. If there's, anything that I should use as an index. So for example, in this particular case, I could probably use ID as a unique index. But we're not going to do that. So the next thing is that you would normally do in data analysis, that is you would describe the data. So you would do df.describe to look at the descriptive statistics. We're actually not going to worry about this step right now, because right now what we want to do is we want to learn about joining the data sets together, or multiple data sets together, or subsetting data sets. So the first thing that I want to show you is how to concatenate data sets together. And concatenating is basically a very simple process. You can concatenate either by rows or by columns. And what does concatenation mean to you, like when I tell you concatenate 2 strings? Yeah, you basically just smoosh them together. The exact same logic applies to concatenating data sets. So essentially, imagine that you have 2 sets of columns, or let's say 2 sets of rows. So if you look at this data here, so let's say I'm going to split it up where my one data frame only will have the columns up to gender, and my second data frame will have the rest of the columns, right? So I essentially have 2 data frames with 2 lists of columns. If I want to put them together, all I have to do is concatenate them by column. So when you concatenate by columns, it basically just takes 2 data sets and puts them together like this. But the assumption is made that both data frames that you're concatenating have the same number of rows. Does that make sense? Because you're basically just smooshing them together vertically. You're putting the columns together, so the assumption is that you have the same number of rows, and then each row contains data that pertains to the same unique identifier or to the same index or to the same record. So it's not a great assumption because a lot of times you cannot do that unless you know for a fact that the two data frames have rows that are ordered in exactly the same way, and that each row in one data frame matches each row in the other data frame. You still do that quite a bit, and we'll still do that a lot whenever we look at machine learning applications. And we will look basically at the values that originally existed in the data set versus predicted values. And we're going to do a lot of, sort of like the sideways vertical concatenation by column. The other type of concatenation that you can do is concatenation by rows. So essentially imagine that you pull data from two separate files, and both files have the same columns. So they have identical columns, and you just basically want to add rows from file A to rows in file B. So basically it'll take file B and add it to the bottom of file A. That's concatenation by rows. So how do we do this? Because my original set of files got corrupted, what we're going to do instead is we're going to bastardize the data set that we have, and we're going to make multiple data sets out of it. So let's do the following. I'm actually going to delete this block of code. So how do I subset this data set so that I would split it into two data sets, one that has, let's say, these 5 columns and another one that has these 6 columns? Any ideas? So what I want to do is I want to take this data set and split it into two, where the first data set A, will have these columns, and the second data set will have these columns. What would be the sequence of steps? How can I select a column from a data frame? How do you select a value from a list by its index?
You type the value into square brackets.
Pretty much. So let's say if I wanted to select the ID column, so df of ID would just give me the first column. What if I wanted to select multiple columns? How do I do that? Exactly. Yeah. So you basically use double square brackets to indicate that you're basically asking for a list of columns. So I'm using double square brackets here, and I'm listing ID, cholesterol, stabilized glucose, HDL, and age. So let's say this is my first data frame. And I'm just gonna save it in a different I'm just gonna save it in a different variable. So I'm gonna say, let's say, df col1 equals to this subset. And df column2 equals to the rest of these columns. So I'm just going to copy them and paste them here. So I'm going to have gender, height, weight, frame, there we go. All right. So now I have essentially two data frames that subset the columns from the original data frame. So the first data frame will contain all the rows from the original data frame, but just for these columns. And the second sub data frame is going to contain all the rows from the original one, but for these columns. Does that make sense? All right. So if we do df column one dot head, you will see that this data frame only has the columns that we specified. And if I do the same thing for the second one, you will see that the second one also has just these columns. Yes? I can try. Yes. Yeah, I'll upload the screencast and I'll upload the code examples. But if you can follow, that's great. If I'm making it too large, it starts cutting off some of the code. Can you see it okay from here? I'm just curious, what does it look like from far away? It's okay, but not great. Okay, so this is an example of subsetting by column. So now we have two data frames. So imagine that you basically pulled these data frames from two different files, or for some reason you received two completely independent data frames, and now you want to smoosh them together. Make sense? Cool. All right, so if I want to smoosh them together, I need to look at my cheat sheet first. So I want you guys to learn kind of how to use this and how to understand what it means. So one of the parameters that you will see a lot whenever you're subsetting data is a parameter called axis. So basically, by default, this parameter, this axis parameter right here, it's set to 0. So if I go, for example, back to my Jupyter notebook, and let's say in here I'm going to say df or pd.concat. So this allows you to concatenate multiple data frames, right? And I'm just going to open and close brackets or parentheses. And if I hit Shift Tab, it's going to tell me basically what it is that I need to provide. And by default, you can see that axis is set to 0. And what that basically signifies is that by default, the assumption is that you're going to smoosh rows together, not columns. So 0 stands for rows, 1 stands for columns. So if I don't specify anything, what's going to happen is that it's going to basically try to take one data set and put it on top of the other data set. And in our case, that doesn't work. We want to smoosh it by column. So if you go back to the cheat sheet and look at the concat function, so what do we need to provide to the concatenated, if I zoom in? So what is this? What are these parameters? So what am I passing to the concat? Data frames in what format? Yeah, so I'm passing a list of, and by the way, you can pass as many, you can concatenate 20 data frames at the same time if you want to. So essentially, the first parameter that you pass to the concat function is a list of whatever data frames you're concatenating. So in this case, I'm only concatenating 2 data frames, and they're named dfcol1 and dfcol2. So essentially, my first parameter is a list. However, if I try to run this again, it'll try to shove one data frame on top of another. And actually, I want to show you what's going to happen. So I'll call this df by col. So data frame by column. So if I run this, and look at this, watch what happens. Yes?
I'm getting that
Yeah. So depending on exactly which version you're doing or you're running, I was actually hoping that mine would throw this warning. It didn't. But basically, before it even concatenates, it should give you a warning that says that the columns between the two data frames don't align. So you shouldn't basically do, one on top of the other type of concatenation, because this is what's going to happen. So everywhere where the columns did not align, which none of them align really, you get NaN, which is not a number, so it doesn't know what it is. So it's broken. So you always have to be, anytime you do any type of concatenation, anytime you do any type of merging, you always want to double check your data. You want to make sure that the merge happened, like the output of the merging or concatenation is essentially exactly what you expect. Otherwise, you're going to run into some major issues. So now that I was able to concatenate my data set, well, incorrectly. So let's actually concatenate it correctly now. So I'm gonna add axis equals to 1. So now it's gonna concatenate the column sets together. And if I run this, now the result looks correct. So let's try to do the same thing for rows. I'm gonna look at the header for my original data frame. So my original data frame, still basically has all the same values as it had before. But what I want to look at is shape. So the shape tells me how many rows total I have. So now what I can do is I can say df row 1. So I'm going to make up two sets of data frames, and I'm going to say equals to df dot iloc from 0 to, let's say, 200. Oops. Never remember the syntax. Yeah, there we go. And df row 2 is going to be df.iloc from 200 or 201 to 403. So essentially, in this case, I split my two data frames by rows instead of by columns. So this is called subsetting by rows. And one of the reasons, if you look at it, I chose iloc because I just want to grab X number of rows, so I don't care about specific positions. If I wanted to grab by index, I could have done the same thing. So if we look at, if we go back and look, let's say, at df.head, you can see that indices were auto-generated. So I could basically do the same thing if I wanted to grab my data by index. Instead of iloc, I could just do this, because my indices are numeric. Do you understand the difference between this and this? So in the first case, in the case of this, I'm subsetting rows simply by their stupid position, by their whatever order they just happen to be in. In the second case, I'm subsetting the row by its index. So it really depends on whether or not you want very specific rows in your data frame, like if you're actually selecting rows with these indices, or if you just want, in this case, like any row between 0 and 200. So this is highly dependent on how the data is sorted. This is not dependent on sort at all. Yes?
When are they different again? When are those two that get you different outputs?
If the data is sorted. So when you imported the data, by default, when you first import it, if you don't specify the index column, then the index is assigned to you. So this is the index, right? So if I sort my data by any column, right? So let's let's do this. Let's go back to the cheat sheet. And okay, so we're just gonna sort values. So I'm gonna go, and before I do this, I'm gonna say df.sort values, and I want to sort this on height. So note that as soon as I sorted this, so this is the unsorted data set. Look at which index appears first now. So essentially, if I use ilock, what's going to happen is it's going to grab just whatever row appears first. So this row happens to appear first. It'll just grab that independent of index. In the second case, it'll literally find rows where the index value is between 0 and 200. So this is like a really critical differentiation. I'm really glad you brought it up so I could actually show you a concrete example. Okay, so now that we have our two sub-data sets of rows, if I want to, what variable name did I make up before? So I had df by column, let's do df by row equals to pd.concat, and I'm gonna concatenate two data sets. So I'm gonna say df row 1, df row 2. And in this case, because I'm simply taking one set of rows and slapping another set of rows underneath, I don't even need to specify the axis parameter. So if we look at this again, by default, axis is 0, which means we're concatenating by row. So if I run this and look at df by row dot head, or actually shape, you will see that all the rows are going to be in there. All the data is going to be in there. So, yeah, we lost a row because of inclusion, exclusion. So,
We want the row 4 to be in row 2.
what? I'm sorry.
We want that 403 to be in 404.
Yeah, actually, because we're doing it by index, I think so. Nope.
It's the 200 to 201.
Yeah, it should be this because 200 is exclusive. Oh, wait, sorry, right here. There we go. Yeah. I'm actually surprised that this worked because it should have thrown an error saying that there's no 404 index, but okay. So this basically gives you an overall idea of concatenation. You have to be super careful with concatenation because concatenation makes an assumption, or it makes several assumptions. So if you're concatenating by column, it makes an assumption that both data frames or any number of data frames that you're concatenating have the same number of rows. If you're concatenating by row, it makes an assumption that the data frames you're concatenating has the same number of columns. So it's kind of the opposite. So you have to be super, super careful whenever you're doing any type of concatenation.
So when do we need to specify the axis and when do we not?
When you're concatenating rows, you don't specify axis. So essentially, imagine, well, this actually has a rather nice visualization. So if you look at this visualization right here, you can see that the two data frames that you're concatenating, the one on top and the one on bottom, they have the same number of columns. So you're just basically concatenating one set of rows to the other set of rows. So they just get smooshed like this. In this case, you do not need to specify axis. If you have two data frames, in this case, they have the same number of rows, so 1, 2, 3, 1, 2, 3, but they have different number of columns. So you have to concatenate them horizontally instead of vertically. Then you have to specify axis to be 1 because you're essentially appending columns. So x is equals to 0 means you're appending rows. X is equals to 1, you're appending columns. It's just that 0 is the default value. So if you don't specify it, it makes an assumption that it's 0. Yes?
So in that case, if one of the data frames has more rows than the other one, will that set of columns just say null?
Yeah. Yeah, or it. I always forget. Like sometimes it says NaN for not a number, and sometimes it actually says Na or something like that. Because there's a function called isNa, which we're going to look at next week, which allows you to determine missing values. So yeah, it basically gives you like a non-existent value essentially. I never remember which one it essentially exactly shows you. So this is concatenation. Concatenation is super dumb because again, it makes these two assumptions, and these assumptions are dangerous. So again, when we start looking at machine learning applications in a couple of weeks, we'll use this heavily because the results of any type of machine learning operations that we do, it's going to match rows automatically for you. So the order of values in the predicted values is always going to be the same as the order of values in the original data set. So it's going to be okay to smoosh two columns together just so that you compare them. However, whenever you're working with data in real world, this is not always the case. So a lot of times you run into situations where this is going to produce results that you do not want to see. So in order to kind of explain this a little better, let's create two more sub data frames very quickly, and we can copy and paste for that. And then once we do that, I'll jump into slides and I'll explain this a little better. So whenever we subset our data frames by column, so I'm just gonna grab this same piece of code right here and copy and paste it at the bottom. So let me actually put a header in here because I'm going to post this code on CourseWeb, so you could reference it. So I'm going to make this a markdown column and call this Concat. And this one we're going to call it merge. Okay, so I'm going to copy this again because I'm lazy and I don't want to deal with having to retype a lot of stuff. I'm just going to name my first data frame df1 and my second data frame df2. And I'm going to add one more thing to this data frame. So note that the unique identifier for my patient is only in the first data frame, right, the ID column. I'm going to keep this column in the second data frame as well. So I'm going to throw ID in here as well. So now both df1 and df2 have a subset of columns, but now they each have a unique identifier. The reason I want to show you this is because this happens more often than you can imagine. So for example, if you think about clinical data in general, so I work a lot with clinical data, which is why I keep kind of bringing up these examples. So for a given patient, I have labs, I have medications, I have pathology reports, I have radiology reports, all kinds of information, right? So essentially all of that information is associated with patient ID. So whenever I get a data set and I want to combine it to get a larger kind of picture of what the patient history looks like, I have to basically merge the data set that has patient's demographic information, data set that has patient's lab results, medication history, and so on and so forth. So at any given time, usually like I have to merge anytime we're doing any type of machine learning modeling exercise with patient data. Sometimes like I have to merge as many as 15 to 20 different data sets together based on different parameters. And the only way for me to know that data from table A matches with data in table B is by that patient identifier. So it's really important that basically whenever you're doing any type of merging, instead of concatenation. Again, I'm differentiating between concatenation and merging. In this case, I'm talking about merging. So concatenation doesn't care about unique identifiers. It just cares about matching the counts of rows or the counts of columns. Merging basically allows you to connect multiple data sets based on a unique index or a unique identifier. So you can take, a bunch of different tables. So we'll start with 2 tables. And we're going to say that for every row in data frame 1, so let's actually run this, and we're going to do df1.head. So what I want to do is for every single row in df1, I want to find a corresponding row in df2 that has this ID. Does that make sense? And then only come back with the rows where this match exists. So actually, for demonstration purposes, I'm gonna go even crazier a little bit, and just so that it's a lot easier for us to see instead of looking at the entire data set. So what I'm gonna do is I'm gonna create a temporary variable. Ooh, what did I just do? I'll just call it dftemp. And for this temporary variable, I'm gonna subset my my df. So first of all, I'm gonna sort values by ID. Ooh. And secondly, I'm gonna say df temp equals to df from, let's say, 0 to 10, or let's just do 5. And then for this, I'm going to subset df10. So I can just display my entire first data frame, and it's going to have 10 rows, which for some reason did not get sorted. Doesn't really matter. We don't care. All right, so.
You forgot to do df on 10.05.
What, I'm sorry?
Like when you do from 0 to 5, when you do df underscore 10.05.
Oh, yeah. Jeez. Thank you. Yay. Okay, that's what I get for copy and paste. Thank you very much. Okay, so hopefully everybody's on the same page with this, and you guys kind of see the pattern. So this is actually like another really important learning objective that I want you guys to take out of today's class is subsetting data frames. Because when you do data mining, you do this all the time, over and over and over again. Like one of the data sets that we're trying to make sense of right now, it has about 8 million records. We're not gonna do this for 8 million records, basically like as a trial and error, because everything takes forever. So, we basically just randomly selected about 500 rows from the data frame, and then we keep slicing it and applying machine learning algorithms to just those 500 rows, just to kind of see what would give us better performance. And then we'll try it maybe like on 5,000 rows before we try it on the entire data set. So you do this type of subsetting all the time. You do subsetting by column once you figure out like which variables actually make sense, which variables actually have predicting value. So predictive value. So for example, as you start looking at the data, you may realize that like age doesn't matter at all, or weight doesn't matter at all as as a predictor for whatever it is you're trying to achieve. So you keep subsetting until you have a nice set of predictors, and we'll learn about this in a couple of weeks. But this is just as a concept, it's pretty important. So now that I have this, and I have my tiny data frame with only 5 rows, Let's look at df2. And it has a few more rows. But now what I want to do is I'm actually going to delete a couple of rows here just to illustrate something. So df2, I'm going to say df2 equals to df2 from 0 to 3. So now you can see that df1 has 5 rows, and df3 or df2 only has 3 rows. So now let's talk about merging. Let's talk about merging in terms of joins. So in SQL, basically joins allow you to connect two data sets on primary and foreign key relationships. Since this is not a databases course and I don't want to go into explaining the whole idea of primary foreign key relationships, basically the way you can think about them is that you have these two tables or these two data frames or these two data sets, however you want to think about them, and each of them has a unique identifier that allows us to link these two tables. So in my first table I have user ID, which uniquely identifies each user in this data set. And in the second table, I have a column called FK user ID, which basically allows me to figure out which user in this table has which address in this table. Does that make sense so far? Okay, so imagine that my data looks like this. So I have two tables. In one table, I have 3 users. I have Mr. John Doe, Mr. Michael Brown, and Miss Evelyn Green. And in the second table, I have addresses for these people. So Mr. John Doe is loaded, owns 2 houses. So, or maybe, maybe it's just like when you are a university student, you're asked to provide a mailing address and a permanent address. So you essentially have 2 addresses here. And then Michael Brown may or may not be homeless, but maybe somebody forgot to record an address for him. And then, Evelyn Green is just kind of like, has 1 home. So, we have basically a wide variety, or in this case, a narrow variety of how data in this table relates to this data, right? So what I want to do is I want to take these 2 tables, and for data analysis purposes or for reporting purposes or for any purposes, I want to combine them into this data set. So what I want to do is from the first table, I want to take these 2 columns. I want to take last name and first name. And from the second table, I only want to take street address, city, state, and zip. So basically what I want to do is I want to smoosh these 2 together. And essentially I want to connect them by this index or by this unique identifier that basically allows me to say that for each row in this table, find all the rows in this table that have a user ID of 1. Then find all the rows that have user ID 2, which they're none, and so on and so forth. So this is called joining tables. And in SQL, which stands for structured query language, these are called SQL joins. In Python and Pandas, they're called merges or merging. So the reason I wanted to explain this to you in terms of kind of database tables because the terminology still applies. So we have an inner join, a full join, and an outer join. And I wanted to show you what they mean kind of like in terms of the stored data before we look at them in Pandas, because then this would make so much more sense, hopefully. So basically, note that in this table, so for user ID 1, we have 2 matches. And in this table, or for user ID 3, we have only 1 match here. There are no matches for user ID 2, so user ID 2 is unmatched. So whenever we join 2 tables in SQL or in Pandas, by default what happens is that the result set only contains the rows that exist in both tables. This is called an inner join. So basically, if user ID 2 doesn't exist in this table, then it's not going to appear in the final data set. I like to think about this in terms of Venn diagrams because I'm a bit of a stats nerd and data visualization nerd. So if you think about this being your table 1 and this being your table 2, the only data that will appear in your final result is the data in this cross section, the data that exists in both tables. And when I say the data that exists in both tables, whatever unique identifier you're using to connect the two tables. So if table A has some unique identifiers that don't exist in table B, then those will not appear in the final results, and vice versa. Whatever unique identifiers you have in table B that don't exist in table A will not appear in the final results. So let's take a look at how this works. Before we look at other types of joins, let's look at how this works in Pandas. So first, let's actually look at our cheat sheet for merging. Combined data sets. All right. So this is our cheat sheet for merging. We're going to start with this because this is something that we probably do most often. So we provide, you can merge two data sets at a time. So unlike concatenation, where you just provide a list of data frames and you can concatenate 50 or 500 data frames at a time, in here you can only do 2 at a time with merging. So whenever you do inner merge, the order of data sets doesn't matter. It doesn't matter which one goes first, which one goes second. Yes?
Can you merge, or can you nest merges in there? So like say if you have like 2 tables that you merge, can you put that in as an argument for merge?
I never tried it. Maybe. I mean, I'm assuming you could probably do it. We could try it just for the hell of it. I don't see why we couldn't. Yeah, you could probably daisy chain a bunch of these, but I never tried it just because merging is such a kind of like, not delicate operation, but anytime I do any merging, I very carefully check the results. So I usually don't like daisy chaining events like this because then it makes, like if something breaks, it makes it more difficult to identify where in the chain it broke. Whereas if you do this kind of step by step, then it makes debugging a lot easier. But just given what I know about Python, I would make an assumption that daisy chaining will work. We can try it just for shits and giggles. So let's start with the inner join or inner merge. So in this case, let me go back and I'm going to say df merged equals to pd.merge, and I'm connecting df1 with df2. If we look at the suggestion, so by default, if you don't specify how, it defaults to inner. And then you also have to specify which column you are merging on. So you have to specify the unique identifier on which you are merging. Now note that there are 3 possibilities here. So you have on, you have left, and you have right. I'll explain the difference. So in our case, if we look at our data frames, in both data frames, our unique identifier is named ID. So it's the same column name in both data frames. So if you are joining 2 data frames where your unique identifier on which you are doing this connection is named the same, then you would simply use on. So you would say on ID. And note what happened. Because the first data frame has 5 records, but the second data frame only has 3 records, because we used an inner join, then only those records that exist in both data frames end up in our final data frame. Does this make sense? Yes?
So it's kind of like you're finding the intersection
Exactly.
between the two sides.
Absolutely. That's exactly right. Yep. That's exactly right. So if for some reason, so let me go back to DF. So let's say in DF2, I always forget how to do this. Rename column pandas. Fine. All right. So my df1.columns gives me this. So I'm just going to copy and paste this. And so I'm going to rename my ID into patient ID, just to show you the difference. So now, if I actually try to do a merge like this, it's not going to work because now in my df1, oops. So if I do df1.columns and df2.columns, you will see that in data frame 1, my unique identifier is now named patient ID, but in data frame 2, it's named ID. So now, if I want to make the same join, instead of using on, I have to actually specify which ID am I going to grab from the data frame that's on the left. So again, if we tab, shift tab, so we have left on and right on. So left on, because on the left I have df1, that's, we're reading from left to right. It's patient ID. And right on is just ID. So you're going left to right because I'm listing df1 as the first one in a merge. I have to do it this way, yes.
Where did add ID come from?
Oh, I just renamed it. I renamed it right here, just to show you the difference. So I deliberately renamed it.
These will look little, I think.
Okay, cool. So now if I run this, it'll do the same thing as the previous exercise, but now basically the only difference is that I'm specifying, explicitly specifying which columns I'm merging on. That's the only difference. Okay. Let's quickly look at more Venn diagrams. Okay. So what happens quite often, as we just saw with the example where I deliberately deleted some rows, you don't necessarily have data that matches in table A and table B. But as we saw, what inner join does, it throws out the rows that do not match. So it only finds the intersection between the two tables and throws everything else out. Sometimes that's unacceptable. Sometimes we want to see all the data. We want to see the data that exists both in table A and table B. And that's why we have different types of joins. So this is called a left outer join. And basically, as the name suggests, or at least the word left suggests, is that in this case, we have the user ID that's missing, or the user ID that exists in this table but doesn't exist in this table. So what we want to do is we want to have a data set basically where we still show all the data from the table on the left and show nulls if it doesn't match on the right. So we want to retain all the data that exists in the left table, and when I say left table, it's simply the first table we list as the part of our merge or as a part of SQL join. So what I want to do is I want to see a result set like this, where we have columns from users table, column from the address table, but still, show Michael Brown even though there's no match here, and just indicate that there's no match by either showing nulls or NAs or nans, whatever you want to do. So this is called a left join. And basically, the Venn diagram for it is this. So it will show you everything from the table on the right, on the left, and only those rows from the table on the right that match. So this basically allows us to get a larger picture and also figure out maybe why the data is missing. So even though the inner join is sort of like the default join in merge and in SQL, left or outer join is pretty much just as important. So let's take a look at how it works. So I'm going to say, again, df merged outer, or let's call it left. Doesn't really matter. I'm just going to copy this because I don't feel like retyping it. And if we look at the cheat sheet one more time and zoom in, so the left join will basically match rows from the left table and show NaN where it doesn't match on the right. Does that make sense? So this is what's going to happen when I actually specify my join as left. So instead of inner, I'm going to say left. And actually print this. So df merge left. So you can see that the last two rows that did not match will show NaNs. So let's screw up the first data frame just so that we could see what happens with the right join. So I'm going to say df1 equals to df1 from 1 to, what was my selection? From 0 to 5, I'll do from 1 to 5. All right, so I got rid of the first record. So now, basically, theoretically, my table on the right has indices 1 through 4, but my table on the left has indices 0 through 3. So what I want to do now is basically repeat the same exercise, but change the join from right to left. And as the name indicates, again, the logic is the same, but now what's going to happen is that we'll get all the data from the table on the right and only the data that matches from the table on the left. So as I said, we have 0 through 2 in table on the left in df2, but since that's unexpected. Oh, because now I have to reverse this, I think. Nope. That's not it. Okay, so, oh no, it's right. Merge data sets create different indices. Duh. Okay, so if we look at this, so patient, we're merging not by index, we're merging by patient ID. So this is correct. So patient ID 101. So let's actually quickly, I'll do this. So df1 and df2. So df1, we have patient IDs 101, 102, 103, and 105. And here we have 1000, 101, and 102. So only 101 and 102 should match between the two tables, right? But because I'm doing a right join, it'll still, basically, it'll find everything that has, so because this table also has an ID 1000, which this table doesn't have, so it'll try to match it. And because it doesn't match, it'll just display NANs. The last type of join, so basically, if you want to think about this again in terms of a Venn diagram, this is what the right join looks like. So you get everything that exists in the table on the right and only the matched rows in the table on the left. So you kind of have to be careful whenever you're working with joins and doing all this kind of stuff. So last but not least is something called full join, or in Pandas it's called outer join. So let's actually, just to stay consistent, this is going to be merged right and merged right. And this is going to be merged outer and merged outer. So if I change this from right to outer, it'll show everything from both tables. So it'll show all the rows in table A and all the rows in table B, but where the IDs don't match, it'll show NANs on either side. Any questions about this? Does this make sense to everyone? So this is super critical for your homework assignment because you will be doing merges. I gave a very similar homework assignment last semester. One of the most common mistakes is that people, basically, whenever you merge stations with rentals, people basically got rid of duplicate stations without thinking that, well, in this quarter, the list of stations was different from the list of stations in the next quarter, and so on and so forth. So even though the station ID may look the same, it's not necessarily the same. So one of the things you want to think about is, instead of, and I'll go through a small subset of the problem with you, just to guide you better, as you are, so you're going to have to do both merging and concatenating in this homework assignment. So the first step would be, as you start thinking about this algorithmically, so we'll look at the data set. So let's say you open this subfolder and you have 2 files in here. So your first step is to actually merge these files. And if you look at the data, let me zoom in a little bit. So you'll have to do actually 2 merges, which kind of, I'm glad you asked that question. So we can try to daisy chain something like this just as an experiment, but you will need to essentially create a triple join. So you are going to do the following. So let me open a text editor so it's a little easier to see. So you will join rentals, or the other way actually. So rentals to stations on from station, and then you will join the resulting data set again to stations on to station ID. So you have from station ID, and then you also have 2 stations on 2 station ID. Another thing that I want to point out right now is that you will see that there's spaces in column names. The first thing you want to do when you open any of these data sets is rename the columns. Replace spaces with underscores or with anything you want, but make sure you rename the columns so that they don't contain spaces, because you're going to run into problems as you kind of go through it. So we'll come back. I want to show you kind of one more thing briefly for about 5 minutes, maybe 10 minutes, then we'll take a break, and then we'll come back. We'll talk more about the homework assignment and kind of like what is a good starting point for your homework assignment. One of the things that I'm going to expect you to do on your own is figure out how to loop. So you need to do the whole thing programmatically. In this particular case, you have, in the case of the homework, you have 1, 2, 3, 4, 5, 6, 7 subfolders. So you will need to Google and figure out how to loop through subfolders. And then for each subfolder, you're going to grab whatever file you're working with and read it in, and so on and so forth. But I'll at least like show you the starting point. Yes?
Could you just put all the files in the subfolders into like make it just one big?
Nope, that's cheating.
Alright.
Nope, because in real life, you know, that's like I actually want you to think through the problem, and you know, and it's super simple, like, you know, how to loop through subfolders, Python. And, you know, you have kind of like ready to go code. And because you only have one level of subfolders, you don't even need the whole thing. So OS walkthrough is pretty much all you need to do, or OS walk rather. So you know, there's so many examples that you could look at. It's no, go away. It's kind of, so I would probably go to the guide to OS walk or Google OS walk. So the only thing you're allowed to hard code is your root directory, so your starting directory. Everything else needs to be dynamic. All right, so the last thing that I wanted to show you from the, well, let's actually, so you can see that there's method chaining here. So let's actually do your experiment real quick, because now I'm super curious how this would work. So I'm going to create df3, and df3 is going to be df2, from which we're just going to grab ID, gender, and height. And then we'll do df3.columns. So we'll keep the first one as, we'll name it new ID. We'll rename gender into gender2 and height into height2. So we basically, this is how you rename columns. You set the property of whatever data frame you're working with, and you assign it a list of column names, and that'll rename all columns in bold. So if I do df3 now, oops. Oh. Sorry. New ID, weight 2, and frame 2. Oh, I'm sorry. I'm being a dumbass. This needs to be, and this is being recorded. So, okay, yeah. So this needs to be a list of columns, double square brackets. All right. So now I have a third data frame. So now if I want to join or merge rather all three data frames. So let's call this df underscore master equals to pd.merge. And let's start with the first two data frames. So I'm going to merge df1, df2, how equals outer, and I'm going to merge them on left on equals to pet ID, right on equals to ID. So let me break this down so you could better see. Okay, so far, if I do df underscore master, this is the same thing as we did before. So what I want to do now is pd.merge all this crap as my first data frame, comma, df3, how equals outer, on equals or left on equals ID, and right on equals to, what did I name it, new ID. Yay. So now we have new ID, weight, and frame 2. So this basically would be how you would want to, how we could potentially merge three data frames together as a daisy chain. I wouldn't really recommend doing it because debugging it will become just a huge pain in the butt. Awesome. So the last, like I said, the last important piece that I want to show you is subsets so where's filter? Group by, oh, filtering. Okay. So basically filter allows you to run these almost like query-like expressions. So what I can do with filtering is basically, and you can think of filtering as if statements. So if statements that basically only show you whatever rows that fit the if criteria. Does that make sense? So if I go back to my df1, so I have my df1, we'll look at it, has 4 rows in it, perfectly fine. So what if I want to only see the rows where, let's say, patient ID is greater than 2000, greater than 103? So what I can do is I can do the following. I can say df1. So it's a lot easier if I just create query. And I'll just say pat ID is greater than 1003. And then what I can say is df1.filter query. And it gives me a list of rows. No, that's not right.
Oh, that's because pet ID is not in df1. That's only.
No, it is.
Oh, that's
Oh, duh. Hold on. So we'll filters for regular expressions, and I don't want to cover regular expressions here, but so instead of doing this, we can do this. Nope. There we go. Okay. So this is an example of filtering or searching within data frames. So essentially, you're given this a Boolean expression. So whenever this expression is true, then the row gets returned. If this expression is false, then the row gets skipped. And you can make these, fairly complex and fairly comprehensive. We're going to talk a little more about querying next week whenever we query for missing values. But the reason I wanted to bring this up is because when you do spot checking of your data in your homework, this will become very, very useful. So you could basically, get a quality. You could say, show me everything where this is true. Again, double equal sign. Or where, pad ID in what are you talking about? In range. No. I guess it doesn't allow in. So you have to do more direct comparisons. But basically, what I want you to do to get started with this, I never remember the syntax off the top of my head. And since I don't have the examples that I prepped in advance.
Could you use and?
So pad ID equals to, let's say greater than 102 and df1 dot, let's say, HDL equals to greater than 24. You should be able to, and I know you can. I just never remember the syntax for it. So give me 1 second. It's not filter. I think it's query. There we go. Query. There we go. Okay. So I mixed up filter and query. So if I do Q equals to, let's say, pad ID is greater than 1002. So what I can do is df1.query Q. Filter uses regular expressions. Query uses direct comparisons. The bizarre thing about queries, and this is to answer your question. So if I do, let's say, everywhere in Python, if you use and, you actually use the word and. So let's say and HDL is greater than, I don't know, 20, right? Oh, this still works with and. In some version of Python, you had to do this, but I guess now both works. Both work. So in older versions of Python, you had to use this and whenever you did Pandas queries, but now it supports both. And we'll actually look at querying quite a bit more next week whenever we actually start looking at dealing with missing values. So let's take a 10-minute break, and when we come back, we'll spend like 20-25 minutes on getting started with a homework assignment. Okay, so let's talk a little bit about the homework assignment. What I'm gonna do is I'm gonna create another file, and I'm just gonna call this file homework tree starter. And right now we have a blank file with nothing else in here. So before we kind of, we get into this, so let's look at the homework assignment first. And I have too many things open here. I think this is it. Okay. So this gives you more or less an explanation of what you need to do. So I kind of already explained, some of the steps in here, including the fact that you have to merge on the two-station ID and that you need to merge in the from station ID. So one thing that you will need to do at some point is you will need to drop the duplicate rows from the final data frame. And this is actually a mistake, not append, but merge. Okay. Well, you can also use append, but that's fine. All right. So the overall plan for this is going to be basically on the Pandas side after you read through the homework assignment. You start by, well, obviously the first step that you need to figure out is how to iterate through the data. But let's assume that you guys figured this out. So I'm just going to do import pandas as PD. And assuming that you figured out how to loop through the file system, let's say I have my root folder, and my root folder is basically the folder in which I am right now. So my start is going to be the folder that I'm in right now, and then the parent folder for whatever subfolders I want to loop through. So healthy write data is essentially my starting point. And then, again, this is something you will have to do programmatically. For now, I'm hard coding it, so my subfolder is, we'll just look at this one for today, and you'll have to figure out how to iterate through them automatically, programmatically for your homework assignment. So I have my root folder and my subfolder. So let's actually open the file. pd.read CSV. And remember, we need 2 data frames. Well, actually, we need 3 data frames. So let's think about why. So first, you need to open the healthy ride data, the rentals data, as one data frame. Then you need to open the station data as another data frame. Then you merge them into a third data frame or temporary data frame. And then once you merge them into that temporary data frame, so remember, you need to keep adding everything to the master data frame. So realistically, you actually need 4 data frames total. So we're going to create, we'll call this master data. And I'm just going to create it as an empty data frame with nothing in it. I'm going to have df rentals and df stations. So df rentals is going to be set to, let's see, root folder plus subfolder plus whatever file name I have here. So I have rentals. Make sure you get all the slashes in place. So it might be easier to actually do it this way. So let me break it down. Do it like this. So this is your DF rentals. I'm just going to make it a different block of code. Oh. Extra space by accident. And then DF stations is actually going to be almost the same thing, but with a different file name. So these are my stations. So now I have two data frames. One is DF rentals. The other one is DF stations. The next step is if we do, let's say, df rentals.head, you can see that all of these have spaces in them. So we want to rename them. So what I'm going to do, and this is just kind of a quick and dirty way to do this, I'm going to print out columns. All right. Oops. So essentially, data frame columns, or it's a list, right? So all I'm doing here is I'm replacing all the spaces with underscores. This is a cheat. Does everybody understand this? Do you guys understand what I did here? And then I'm going to do the exact same thing for DF stations. So all I'm doing is I'm replacing column headers, spaces and column headers with underscores. Now this is where things get really exciting. Let's look at column headers one more time. So df rentals.columns and df stations.columns. So if we look at these two, and if I want to create a master data set out of these two items, the columns that I need to connect to, so I'll need to do a triple merge essentially. So the first merge is going to merge rentals to stations on from station ID, and the second merge is going to merge it on to station ID. And we're linking to station ID and from station ID to station num. So at the very basic level, I'm going to do one merge. You'll have to do the second merge on your own. So let's say I'm just merging two data sets. You're still going to need to merge the third. So I'm going to call this df merged equals to pd.merge. And what I want to do is say which data frames I'm merging. So I'm merging df rentals to df stations. How should I merge this? So this is a question that I want to discuss because it's important that you guys understand this. Which type of merge do I need to use? And why? So we have inner, left, right, and outer. So inner will give us only the data that matches between the two. Outer will give us everything and just show nulls for things that didn't match. Left will give us all the data from the rentals table and show nulls for stations that don't exist. And then right will do vice versa, show us all the stations and only the matched rentals. So in this case, which one do we need to use? Inner, left, right, or outer? Yes.
I think left.
Okay, why?
Probably more rentals than there are stations. And you're interested in the rental information.
So most of the time I would agree with you. So the answer is it depends on what question you're trying to answer. So if I'm trying to answer, how many bikes should be at any given station at specific times of day, I probably don't care about, the ones that are not matched. So basically, most likely the ones that didn't match for some reason are, errors anyway. So somebody basically recorded a bike that doesn't belong to a station, that doesn't give me any valuable information. So we're going to kind of talk about this a lot, especially when we actually start looking at research questions and machine learning approaches to answer those questions. But in this case, I would probably stick with an inner join because I only want to see the matches. Because the question that I'm trying to answer is, how should I rearrange existing bikes among existing stations? So if I have rentals, but I don't know what areas, like if the station IDs are incorrect, so that doesn't give me any information about where those rentals were made, if that makes sense. So then they're not particularly useful to me. So I would do inner and then left on. So left on would be from station ID. And I believe these are case sensitive, so be careful. And then right on, oops, equals station num. So again, from station ID is the unique identifier in the rentals that needs to match to station num in the right table. So if we look at df merged, let's just look ahead. So you can see that now each rental is matched to a station. So generally speaking, and for this homework assignment, I'm not too worried about stuff like this, but anytime you're doing this type of exploration, so we need to validate if whatever we're doing is actually correctly joining the results. So basically, the first thing that I want to do is I would look at df rentals.shape, and I would look at df stations.shape. So we have 50 stations, and we have almost, we have over 9,000 rentals. We have a total of 15 columns, right? So that my result set, if I do df merged dot shape. It should have 15 columns. You will also notice that there are fewer rows in the merge data set than in the original data set here. And the reason for that is because there were some mismatches. So apparently in this data set, there were some station IDs that didn't exist in the other one. And if we wanted to filter, so basically we could say df stations dot, let's say, what is it, station num. Okay, so this gives me the station numbers. So if we do, I wonder if this will work. I'll have to think about this. Or an easier way to do this would be actually to use a full join and just see where things don't match instead of writing a query. I'll have to think carefully about a query here. I'm used to doing this in SQL, but not really in Pandas. So we'll kind of skip that part for now because I don't want to embarrass myself by writing a query that doesn't work without actually trying it first. So essentially, you know, these are the things you need to do before you're actually trying to do merge. So, you know, do as I say, not as I do. You need to kind of do due diligence. You know, you need to look at the shape. You need to look at the column names, make sure that you're joining the right two things, more or less. So then the next step, once you're actually, you know, once you've actually merged this data frame, the next step is, you know, next step, merge df underscore merged with whatever the next, you know, with stations on to station ID. So you will basically need to add another merge to this, because you want to know which stations bikes were rented from and which stations they were returned to. So you're kind of building this master data set. The last step, so last step in your loop. So remember we declared this master data. So you would just say master data, or actually, yeah, master data equals pd.concat master data, oops, comma, df merged. So every time you create a new merge data frame, you want to append it to the end of master data. So just to show you, you know, we could do so, oh, because I already ran it. So let's do this from the beginning. I'm going to clear my output. Or actually not even clear my output, but just reset master data. So if I do master data.shape, by default it's empty. So if I add this and run this, now I have all of my rows. So every time I concatenate the new merge data frame, the number of columns should stay the same, but the number of rows should increase. Does that make sense? So essentially, you will do this for every subfolder. You will generate two data frames that contain stations and rentals. You will merge them together, all inside of that loop. Then you will append it to the master data set and just keep doing it over and over and over again until you run through all the subfolders.
So, what is the from station to station? What are those? Are like how do you want like
The,
Or is that where we're getting, like, are we trying to get information about each from station and each to station for each trip?
yes, exactly. That's exactly what we're trying to do. So the reason I want to do this now is because at the end of the semester we're gonna do network analysis. So we're actually gonna come back to this exact homework assignment, and you're gonna build on top of it. So the master data frame that you build, we're gonna want to see how the network of rentals and returns affects the number of bikes at each station. So we need to have geographical information about both the rental station and the return station, and that exists in the station data set. Yep.
So the final master data set should be one large data set drawing from all of the subfolders, and it should contain all of the trips, the data on the from and to stations.
That's exactly right. Yep, that's exactly right. And then your very, very final step would be, you would just do PD, or not PD, but master data dot to CSV.
Okay.
And that's outlined in the homework assignment. And let's say, master rental data dot CSV. So if I run this, and you will see that it saves almost instantaneously. So if I go back into my folder, now I have a CSV file with my master data, and it has all the information about my rentals. So you will have essentially, let me zoom in a little bit. So from station ID to station ID, so you will essentially have these columns repeated for from station and to station. Does that make sense?
Yeah.
Make sure you read the homework assignment very carefully, because I give you very specific instructions on how to rename these columns, because Pandas will not allow you to have duplicate column names. So whenever you're creating your master data set and whenever you're working with your data, you will have to rename your columns in a specific way. I just kind of, as I was demoing it, I showed you a cheat, but in the homework assignment, I'm giving you very specific instructions as to how to rename the columns.